Hello student, welcome to aimsindia's online classes. In today's video from physics subject, force and laws of motion topic we are going to discuss. So in this chapter children, the topics we are going to cover in this chapter are first introduction, next causes of motion, next about force, again in force, balanced and unbalanced forces, Galileo's idea of force and friction, Newton's first law of motion, about Newton's second law of motion, mass versus inertia, what is the difference between them, and Newton's third law of motion, and finally about conservation of momentum. So about all these topics we are going to cover in this chapter children. So first let's begin with introduction and causes of motion and force. If you observe this picture children, so all the vehicles are stopped here due to the signal of this traffic police, due to the signal of this traffic police. So when he says stops or as per his directions, the vehicles will stop or the vehicles will start. Means suppose if a vehicle is stopped, so up to what time, up to what extent it will be in that position when he or when the traffic signal, if the red light comes, then we will stop our vehicle. If the orange light comes, we will keep our vehicle ready. If the green light comes, we will start moving. So means until and unless some other external force is applied, until that time we will be in rest. So when we start the engine, when we raise the accelerator, then our vehicle starts moving. So here a is a body which is under rest will continue to be under rest until and unless external force is applied, or a body which is moving continues to be in motion until and unless some external force is applied. See here in second picture, all the buses are moving in random directions. They are not at all stopping. So if there is some force to stop them, so then only they will get stopped. Otherwise, they will move continuously like that only. So here, children, we might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. So we too, we slow down our bicycle, so whenever needed, by applying the brakes. By applying the brakes. So actually here question is, why a vehicle slows down when brakes are applied? When brakes are applied. So not only vehicles, any object moving on the surface of another object slows down when no external force is applied on it. So finally it stops. So suppose if you take a moving ball, so moving ball after rolling for some time, then it will stop. Then it will stop. Or here, while running, this boy is slipped onto the ground. So because of this banana peel, suppose this boy, he was supposed to run on the wet floor and he slipped onto the floor. Now we are slowing down our vehicles, or we are stopping our bicycle with applying brakes, or object slows down when it is rolling on the ground, or a moving ball stops after rolling for some time, or when we will fell down on the floor onto the floor when we keep our leg on the banana peel, or when we are running on wet floor, we will fell down. So all these things whatever we have told here. So all these things will be happening around us. So the reason for all these things we are going to learn in this chapter. So the reason behind all these things, so why they are happening, so the reason we are going to learn in this lesson. So here, these are all things happening because of a phenomena called friction. Because of friction, and we are going to learn about the force of friction. So friction is a phenomena relating to force. Relating to force. Suppose we have a book on a table. So in the beginning, it was at this place, this position. So if you gently push it forward towards right side, it will move for some distance, then it will stop. So if you repeat this activity, pushing the book from opposite direction, from here, it will move for some distance, it will stop. So 2 times from left to right, while you are pushing the book from left to right, or when you are pushing from right to left, in both the cases, the book is stopping after traveling certain distance. So why it is stopping or why it is moving? It is moving because you have applied force. And after applying force, only while applying force, your hand is in contact with the book. You have applied force only for one time. But after that, the book is moving and book is stopping after traveling certain distance. Is it stopped by your hand? No. But why it has been stopped after traveling certain distance? For movement, with our hand we have created some force. In the same way, it has been stopped by some other force which is not shown here. So the book has been stopped after traveling certain distance because there might be some force working opposite to the movement of the book. So that's why it is stopped. It has been stopped. Why we are using the word opposing? Because if it supports motion, then it might have traveled some more distance, longer distance. It won't stop. So it is stopping means the book is traveling forward and some force is acting backward. So that's why it has been stopped. So that stopping force or the force which is used to stop the motion is called force of friction. Means opposition to motion. That kind of force is called friction here. That kind of force is called friction. So if you apply the force along the left, friction acts along the right. If you apply force along the right, then friction acts along the left. In both cases, force opposes the motion of the book. Which force? Frictional force, not applied force. Frictional force opposes the motion of the book. The force of friction always opposite to the applied force. If the applied force is in this direction or motion is in this direction, then friction will be opposite in this direction. In this direction. Next. So in the above activity, the force of friction acts between surface and book and surface of the book and surface of the table. That we have to observe, because here the book is moving on the table. The book is moving on the table. Means the bottom portion of the book and the upper portion of the table are in contact with each other. Bottom portion of book means surface 1, S1. Upper portion of the table means let it be S2. This S1, S2 surfaces are in contact with each other. Between the surfaces in contact, this force of friction will work. This force of friction will work. Suppose this ball, if you observe this ball, it is flying onto the ground. It is flying onto the, it is hitting the ground and flying back into the air. Means at the moment when it touches the ground, then between the surface of ball and between the surface of grass, friction will work. Friction starts working. Friction starts working. So before that, when it is in the air, there will be no friction between ball and the grass. When it touches the grass, at that moment only, the ball will experience friction. So when it is in the air, then it will be in contact with the air, surface of air. There may be friction between surface of ball and surface of air. That is friction because of air. Friction because of air. This is friction because of ground. So friction will be experienced. So whenever two surfaces are in contact. Whenever two surfaces are in contact. Now the question is the friction same for all kinds of surfaces, or does it depend on smoothness of surface? So let's find out the answer for that. So we can find the answer by one simple activity. So by this activity, we can learn regarding factors affecting the friction. Factors affecting the friction. So how to do this activity means, so tie a string around a brick. So first we have to take a brick, and around the brick we have to tie a string. We have to tie a string. Next, pull the brick by spring balance. So this string to be attached to the hook of a spring balance, and we have to pull the brick with the help of spring balance. For that we need some force. With our hand we can drag it. So we can apply some force and we can note down the reading in the spring balance. Reading in the spring balance. So note down the reading on the spring balance when the brick just begins to move. So it gives you, the reading will give you force of friction between the surface of brick and the floor. Means because the brick is on the floor, means the surface of brick and surface of floor are in contact with each other. When you are when you are dragging with spring balance, when the brick starts moving, when the force applied by you is more than frictional force applied by the surfaces or between the surfaces, then only block will move. Means when the block is moving, means that measurement will be equal to force of friction. Force of friction. So now children, now wrap a piece of polythene around the brick and repeat the activity. So around the brick, now we have to wrap a polythene bag. Now we have to drag the brick with the polythene bag with spring balance. Do you observe any difference, children? Or if you repeat the activity by wrapping a jute bag around the brick, and if you drag with spring balance, will there be any difference? Compulsorily, because the surface of brick is different, the surface of polythene bag is different, the surface of jute bag is different. Polythene bag will be somewhat smooth, so with less force we can drag it, whereas brick is somewhat rough, jute bag is somewhat rough, surface is somewhat rough. At that time we have to apply more force, because there will be more friction because of the rough surface. Because of polythene bag, because of smooth surface, friction will be less. So the frictional force depends on the type of surface. whether it is smooth or rough. Based on the type of surface, the frictional force between the surfaces will be changing, and the applied force also will be changing. So next challenge. If you observe this, you are trying to push or pull a block on the floor. If you observe, if you take the microscopic view of this situation, means suppose the surface, this surface, this is the surface of block, this is the surface of floor, this is the area of contact, surface area which is in contact. If you observe here, there are so many, though it is looking like flat, for normal view the surfaces are looking like flat, but if we see the consider the microscopic view, there will be so many irregularities between the surfaces. So because of these irregularities between the surfaces, so friction will be created. Okay, next. So smooth surface will show low friction, so we have to apply small push for moving this block or small force for moving this block. But rough surfaces, so many irregularities between the surfaces will be there, so they will show high friction, so we have to apply a big push or more force we have to apply to move the block. So friction is caused by irregularities on the two surfaces in contact. So like this, irregularities, because these are the irregularities of the floor, and these are the blue color irregularities of the block. Irregularities of the floor are different, irregularities of the block are different. So these two irregularities lock into one another. When an attempt is made to move any surface, so this part downside, this curved part gets and locked with this part. This part gets locked. Two irregularities between the two surfaces will get locked. When we have to move them one over another, we have to overcome this interlocking. We have to overcome this interlocking between the surfaces. So that's why we have to apply the force. So because of rough surfaces, so large number of irregularities may be there, interlockings will be more, so frictional force should be greater. For smooth surfaces, irregularities will be very small, very minute, so frictional force will be less, so less force we have to apply. Next, another activity. So make an inclined plane, means which is not straight, which is not horizontal, which is not vertical, which is lying at some angle with the ground. It is called inclined plane. So this is inclined plane. This is inclined plane because with the vertical it is making some angle, or with the horizontal it is making some, suppose this is the vertical line, with vertical it is making some angle, with horizontal it is making some angle. It is an inclined plane. So we have to make an inclined plane on a smooth floor or on a table. So with a wooden board supported by books or bricks, we can make an inclined plane. So put a point A on the inclined plane. Now a pencil shell move down from this point. How far does it move on the table before coming to rest? We have to note down that. So first we have to mark a point A on the inclined plane. From there, a cell which will be available in your house. Take a cell, take a pencil, take a wall clock, a pencil cell, take a pencil cell, a small cell or a normal, any kind of cell, and drop it from point A and observe how far it moves on the table and note down its position. So now on the table means in the first case the pencil is moving on the table. So next, spread a piece of cloth over the table. So make sure that there are no wrinkles. There are no wrinkles in the cloth. So it should be flat. So try the activity again and note down the distance again. Note down the distance again. How far the pencil has moved. Now repeat this activity by spreading a thin layer of sand over the table. In all three cases, maintain the same slope, same kind of inclined plane. So after 3 times after rolling the pencil, what do you observe? In which case distance will be minimum? In the sand, while we have rolled the pencil with sand on the table, at that time distance will be minimum. Why? Means the sand surface will be somewhat rough. So whereas when you have used cloth, the cloth will be smooth, so that it might have been rolled for longer distance. So the distance traveled by the pencil also depends on the smoothness of the surface. Depending on the type of surface, the distance traveled by the pencil will be different. So the smoothness of the surface will affect the distance traveled by the pencil. Or in this animation, we are rolling on the same inclined plane. We are rolling different kinds of objects. One is looking like square, next also looking like some cork piece, next looking like a bangle, next one like football, next one like a green color ball, like that. Different objects we are rolling on the inclined plane. All are made up of different materials. So that's why some of them come early. This square block is touching the ground early. And this bangle shaped one is touching the ground late. So like that. Because the surfaces in contact are different. So that's why time taken by them to reach the ground also different. Okay, children. Friction is caused by irregularities on the two surfaces in contact. So even though the surfaces appear very smooth with our naked eye, but they might be having large number of minute, very small irregularities as shown in the figure. So it is book and table. Surface of book, surface of table. Both of them, they are looking smooth. But if we see with microscopic view, we can observe minute irregularities between them. So these irregularities, when we keep book on the table, the irregularities of the book lock with the irregularities of the table. Means they locked into one another. When we apply force to move them, we have to overcome this interlocking. So on rough surfaces, this interlocking will be more because of more number of irregularities. So for rough surfaces, force of friction should be greater. For smooth surfaces, force of friction should be lesser. So okay, children. So remaining topics. That's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, www.aimstoday.in, for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding skills, and lot more. Thank you, children. Have a good day.